So hello everyone, welcome to the first video of our RPG series. Today we are diving into the locomotion system, but since this topic is pretty expensive, we will break it down in multiple parts, and in this video we will focus on our walking, running and crouching mechanics with complete inverse kinematic for a realistic food placement. Plus we will create a stunning pool, and we will also work on our swimming system, and all the animations and assets that will be used in this project, you can grab them from link in the description. So let's get begin. So here for this complete game project, we will use our third person template, and first thing first, we will import our all unarmed locomotion animations here. So simply drag and drop all the animation inside our content browser, and under skeleton select our SK mannequin. And if you are using your own animation, then make sure to use the desired character as per your need. And once we will have all our animations inside our project, then we will start working on our animation blueprints and blend spaces. So here, instead of just using our third person animation blueprint, what we will do, we will create a new one and we will work on it from scratch. So first thing first, create a blend space 1D. You can also create blend space. This is for the multiple direction. If you wanna move your character in multiple direction, then you can use this, but I'm using this blend space 1D for now, and this will be for our unarmed running and walking thing. So name it whatever suits for you, and double click to open it. And once it will be open, under our this horizontal axis, just rename it as a speed, and under our max access value, you have to type the maximum walk speed of your character. And if you don't have an idea about maximum walk speed of your character, what you can do, you just have to open your main character's blueprint, and inside this you just have to select this character movement and then search for max walk speed. And there you can see this is our maximum walk speed, which is 500 centimeter per seconds. So we have to type that here. So it's 500, and just save it. And now we will add the animation in our this graph. So we will not add idle animation here first. You will get the idea why I'm doing it. So what you have to do, you just have to add this walk in place animation first, and then we will go with our walking animation, which is this one, and in the last we will add our this running animation. And if you will just press Ctrl and hover your mouse above this graph, then you can see the transformation of our all three animations. So once it will be done, just simply save it. Now come to your content browser again, and here come inside your folder, this RPG folder. Make sure to arrange your every blueprints and all stuff properly. And here simply right click, and under blueprints create a new animation blueprint. Name it whatever you want, and here inside of this animation blueprint we will create a new state machine. So what does this state machine actually does? So basically it provide a graphical way to break the animation into a series of state, which you will get the idea here only. So just simply open this state machine, and inside this add a new state. This is going to be our sub states. First one is going to be our idle state. So this is our idle state, and always make sure to save your progress, otherwise if it will crash you will lose everything. Okay, so here what we can do, we will simply just drag my any animation, any idle animation here, as it is a idle state. So you can drag any of the idle state here, and you can connect it with our results. So our character will play this idle animation, compile and save it, but I don't want him to always play this single idle animation. So what I will do, I will disconnect it from here, and here I will search for a node called random sequence player. So what this node will actually do, it will play the given animations randomly instead of playing a single animation. So it will be look more better. So you just have to select this, and inside this index you just have to add all your animations, and you just have to connect it with our results. So now it will play our random animation. Whenever our player will not move, it will play this. Now we will add another state, and this will be for our walking and running. And here we just have to drag our blend space that we created for our running and walking, and here under the speed simply promote this as in variable. So this will actually define our actual speed, and by this speed our animation will be blended or transform. Okay, so come to our event graph. From this node search for get velocity, and from this get velocity search for a vector length. And now simply drag our this speed variable and set it here, and connect our speed with our vector length. Now come back to our animation graph. Now we want to make a transition between them. So what I will do, I will open this thing, and here inside I will get my speed, and I will search if it's greater than 0. So whenever it will be greater than 0, then it means we are walking or either we are running. So it will play this walking and running. Now we want to go back to the idle state after we stop. So instead of directly going to idle, what I will do, I will make a new state, and this will be about to idle, or we can say stopping animation. So inside we will search for our stopping animation, which we have here. So I will simply drag it and drop it. And if you have a random more than one animation for stopping, then you can use it the way we used in the idle for the random animations. And for this transition between our running and about to stop, we will again get the speed, and we will search is less or equal than 0. So it means whenever our speed will be less or equal than 0, it will be just play the stopping animation. Once the stopping animation will be over, we want our character to go back to our idle state. So for this, we will select this transition, and here just make sure to turn on automatic rule based on sequence player. So what it will actually do, as soon our stopping animation will be over, it will switch the animation state to idle. Now come out of your state machine, and instead of directly connecting this with our result, what we will do, we will save this in a chess pose, and we will name it as a locomotion, or you can name it whatever suits for you. Now how this chess pose actually works, so it is a way of storing our all this state machine information into this node. It's something similar like our custom events. Now from the result of our output pose, search for our saved pose, which is locomotion, and compile and save it. Now open your character's blueprint, and we are going to change our NM class with our new animation blueprint that we created. So simply come here and under NM class, select our new animation blueprint that we created, and now let's give it a try. So here you can see that whenever our character will be in the idle pose, it will play one of those animation randomly, one of those idle animation randomly. And there is one more problem, that right now we are not walking, we are directly running. So we have to set the max walk speed inside our blueprint. So open your character's blueprint, and before that go to a third person folder, and under inputs we will make a new input action. So right click on your content browser, and under input select input action and rename it as AI sprint, and you don't have to change anything inside it. And after that, open your input mapping context here. If you are using a custom character, then make sure to make a new one. Here we will assign that action that we created here. So open your IMC and add a new mapping and select our sprint action, and under this selection key, select your desired key. In my case, I'm using left shift, and just by clicking this add icon, you can add more keys or inputs like for your controller and all other stuffs. And later on we will also add the inputs for our controller. So save it for now and come back to your character's blueprint, and here search for our sprint input, which is IA sprint, and now make two custom events, one for our start sprinting and other for our stop sprinting. And we also have to create two variables of float type, one for our walking and another one for our running. You can set the value as per your need, but in my case my walking speed is 250 and my running speed is 500. Now drag your character movement into your graph, and from this character movement search for set max walk speed. Connect the execution pin with our custom event, copy and paste the same node for our stop sprinting custom event, and now we will set our speed. Here in start sprinting, set max walk speed as running, and on stop sprinting set it as walking. So what it will actually do, whenever we will press our left shift while moving around, our maximum speed will be increased by 500, which is our max speed, and soon we will release it. We will come back to our normal walking speed, which is 250. And for achieving this, come to our this action, and from start search for our start sprinting custom event, and on completed search for our stop sprinting custom event. And we want to set our max walk speed as walking as soon as the game will start. So what we will do, we will copy this node from here and we'll paste it here, and I will connect it with this node. This is our actually begin play. Oh, actually I forget to just add the character movement here. So simply drag and drop it here, and yeah, we are all set, done. So let's give it a try. So here inside my game, you can see this is how we are walking, and if I'll press sprint, then we are running. So you can see how smooth our transition are, and yeah, it's looking very good. So now let's move to our second thing, which is crouching system. So here inside your blueprint, make sure to always properly arrange your codes. Otherwise, if you will mess up, then it will be a bit problematic to work on with a large code. So just make sure to comment them and arrange them properly. And now again come to your character's blueprint, select our this character movement and search for can crouch and make sure to turn it on. And from here only you can change the max crouch speed, and here it is 300 and that's good for me. You can also play with the crouch height and we will work on it later. Now we will create one more blend space for our crouching animation. So create a new blend space 1D, or you can even go with the blend space. Name it whatever you want and double click to open it. And inside this we don't have to do anything, just set the max access value as your max crouch speed, which is 300 in my case. Now drag your idle crouch animation in the graph and then add your crouch walking animation in the end and then save it. Now open your animation blueprint and here we will create a new state machine. This will be our main state machine. Name it whatever you want and open it. Here from this entry add a new state. This will be our locomotion, our idle and running one. Name it locomotion and open it. Here search for our saved pose locomotion that we created before and connect it with our result. Now from this locomotion add a new state for crouching, and from this make a new state crouch, and from this crouch again make a new state of stop crouching. Now let's take a deep look at them. This is going to hold our stand to crouch animation. The crouch will carry our blend space of crouching, and this stop crouching will play the crouch to stand animation. So firstly open your crouch state and drag our crouch blend space, connect it with our output animation and drag our speed variable and connect it with our blend space. Now open our crouching state and drag stand to crouch animation here and connect it with result. And the last one, open stop crouching state and drag crouch to stand animation and connect it here. Now come to your event graph and from here try get on owner, get a movement component, and from this search for a is crouching and then promote as a variable to this return value and name it whatever you want. Come back to your animation graph and by double clicking open the transition, then drag and connect our climbing variable here. That means whenever our climbing will become true, this transition will happen. Now open the transition between crouching and crouch here and search for node called time remaining many stand to crouch and then get a greater than node and set the time something like 0.2 and connect it with our return value. Now open the transition from crouch to stop crouching and drag our crouch variable, and from this search for not boolean and connect it with our result. Lastly, from stop crouching to locomotion, just select our transition point and turn on the automatic rule based on sequence player. Now we are good to go. Come to our characters blueprint, and for test I will use C key. Later on we will change it with our input action. For now we are using C key, and from this press we will search for a flip flop, and from this A of our flip flop search for crouching, and from B search for uncrouch. And one more thing, inside this transition between our crouching to crouch, change the rotation node with our only remain many stand to crouch, and also here arrange and comment out for your understanding. And from this main state we will save it in a cap pose, name it whatever you want. Then delete this node from here and connect our main state saved pose, which is main. So now you can see it's working, but our camera sucks, so we have to fix it. Again come to your player's blueprint and here select our spring arm and search for lag and enable the camera lag and set the lag speed that suits for you. In my case it's 25. Let's give this a try. So here inside of a game you can see, if I will go to my crouch position by pressing C, then you can see there is no camera glitch here and it's very smooth. So you can set the camera lag time as per your need, and that's perfect for me. And you can see our crouch movement here, it's also good. Now what I will do, I will create a small setup here to test our crouch capsule collision. Whenever our player will be in the crouch position, we wanna check how long, how its capsule collision is gonna look like. Then come to your player's blueprint, select our capsule collision and search for hidden in a game and make it false. And now inside of a game you can see that whenever we will crouch, you can see our capsule collision size, which is very less here. So what we will do, we will go inside our player's blueprint and select our character movement, and then we will search for crouch and we will set the crouch height as per our character's need, and in our case it's 72, and you can obviously play with the values if you want. And now inside of a game you can see that our capsule collision is correct in size. And now come back to your player's blueprint and don't forget to set the capsule collision enabled to be hidden in the game. And finally inside of a game you can see that we can crouch and we can run and sprint, we can walk and sprint. So it's working. Now one more thing I want to show you. you can see that whenever I will climb on this type of surface, my foot placement is not perfect. So now we will fix that and we will work on our IK system. But before working on that, what I wanna let you know how this IK system is different for our FK systems. So let's hop into our Blender to understand this. So here you can see on the right hand side I have my forward kinematics, and what this forward kinematics actually do. Inside this forward kinematics, each bone follows the parent bone's behavior. I mean, here if you wanna make any animation or you wanna work on it, then you have to move every bone for your animation, while on our right hand side we have inverse kinematic, which means a single bone can affect all the attached bones. So let's see. So in our left hand side, this is our forward kinematics. So here you can see if I wanna pose this bone, then I have to just manually arrange them like this only. But on other hand, if we will go for our this inverse kinematic, then there you can see I will just select my this last tailbone, or what we say the foot bone for example, and if I will try to move it, then there you can see that it will control the complete bone sets and it will automatically arrange. So this is a very effective way to work on with animations, and we are going to use this inside our foot placement. Now here you can see that is what we are actually going to do inside our Unreal Engine. So we will do a line trace from our foots towards our ground, and on hit we will get this end trace vector and we will get this distance. So what we will do, we will snap our leg at that distance and the inverse kinematic will do its work. So it's very easy. I hope you're getting it. So let's come back to our Unreal Engine project, and luckily inside our third person template, Unreal provides a pre-built foot IK, so we don't have to do anything for that. We can directly use it here, and if you want me to create a complete video on this, then let me know in the comments. Now come to our animation blueprint, and here search for a control rig node and connect it between our output pose and our main pose. And now by selecting our this control rig, under details, come under control rig class and select our basic foot IK, and now in our output pose turn on this should do IK trace, and inside our node here make sure to turn it on, and yeah, we are good to go. So let's give this thing a try. So there inside our game you can see that our foot arrangement. It's following our inverse kinematic, and you can see it's arranging properly even though we are crouching. And if you don't want this foot IK while you are crouching, then you can also remove it from our animation blueprint only. We will look that in future. And now it's working. Then now we will go ahead for our swimming system and our water body and all stuffs. So let's go ahead. Here firstly we'll create a base for our swimming pool. So just duplicate and place the objects from our map in order to create a base for our swimming pool, and you can definitely make it as per your needs. And then go inside the plugin and make sure to turn on the water plugin and then restart your editor. After that, under place actor, search for water body custom, and obviously you can use a water body lake or ocean, whatever suits for your game, but here I prefer this water body custom because I'm creating a swimming pool here. So just drag it inside of a map and adjust it as per your need. And now if you will try to just go inside this water, nothing will happen, as because right now there is no physics here, so we have to work on the water physics and all stuffs. Now search for a physics volume and drag anywhere in your map, and under details make sure to turn on the water volume. Now what will happen, if you will go inside this physics volume, our animation mode will change into the swimming mode. As you can see, we cannot control our character when we are inside our this physics volume. This is because there is no input for swimming. So now we will add inputs for our swimming. So open your character's blueprint, and here before that movement input, which is AI move, add a branch and then drag our character movement inside our graph, and from it search for a node is swimming and connect the return value with our condition of a branch. And from false search for add movement input and then drag your follow camera, and from it get a world rotation, and then lastly get a forward vector and connect it with our world location. And don't forget to connect the Y value with our scale value, and now arrange and comment it for your understanding. Now what this input node will actually do, whenever we will give any command to our character or our player, it will check whether our player is swimming or not. If it's swimming, then it will get a forward vector of our camera and move our character on Y axis. So let's see how this thing is working inside our game. So here you can see, soon I will enter here. Now my input mode is changed. Now I can actually control myself inside this water, and it's working absolutely fine. So let's go ahead for our blend spaces and our animation stuffs. Come to your content browser. Here at your desired location, animation, create a blend space 1D, or you can also go on with blend space. Again, name it whatever you want and open it. And inside this, you don't have to do anything with our assets detail. Only in our max axis value, rewrite your max swimming speed. Now under your assets browser, search for your idle swimming animation and drag it on the first. Then search for swimming on a surface and drag it on the middle. And lastly, search for swimming underwater and drag it in the last. Then save and close it. Then open your animation blueprint and inside the main state from this locomotion, drag a node and create a new state. Name it swimming and make a back transition. Then open this swimming state and inside this drag our swimming blend space and connect it with our output. And under speed, drag our speed variable and connect it with our speed. Now come to your event graph and from get moment component, search for is swimming and promote as a variable to this return value. Connect it with the execution pin and rename it as a swimming. Now come back to animation graph and here on our this first transition, simply drag our this is swimming variable and connect it, and do the same for our another transition. Now come back to our first transition and here you from our this variable search for not boolean and then connect it. So what will happen here when we are not swimming, it will not play this animation. So now let's give it a try. Now here inside our game you can see that it's working absolutely fine, but there is some glitch in our animation whenever our player moves. So we have to fix that. So open your character's blueprint and inside this select our character's movement and here search for swimming and set your max swimming speed whatever you want and make sure this to be the same value which is inside our blend space. In my case it's 400 centimeter per second, and under braking deceleration make it 500 and buoyancy as 1.5, and feel free to play with these values. So let's give it a test again. So here inside my game you can see that it's very smooth and more perfect than earlier. Now what we will do, we will simply move over this physics volume inside our pool and we will adjust it properly. So let's give it a try. There you can see that it's looking kinda good, but still something is missing there, and that is our swimming speed is directly on our max speed. I mean, there is no option for swimming slow or fast, so we have to add that swimming speed. So open your player's blueprint again and here under our sprint custom event from this character movement search for set max swimming speed and connect it with our execution pin and do the same for our stop sprinting and set your desired value as per your need. So what this node will do, whenever we will press our shift key while swimming, then it will increase our max swimming speed, which will also show results in our animation. So let's give it a try. So here you can see that it's looking and working absolutely fine. You can see that our speed is now in our control. So that's enough for this video, and we created our sprinting, crouching and swimming system and all are integrated together. So if you have any query, feel free to ask in the comment section, and you can join our Discord server for more updates, and you can support us on Patreon. Bye bye.